This memorization quiz. Next week is February. We started talking about this memorization in December, so it is time. Monday, we'll have a memorization quiz. So I made a practice one. Obviously, I can't put every single thing on the quiz, but this is what the quiz will be like. Alright, sit up, sunshine. Look alive. Alright, did everybody get one? Alright, so here we go. So notice that some of it's, there's just all kinds of questions on here. So the first one is, which function is opposite over hypotenuse? When I say opposite over hypotenuse, what is that? Sine. And you'll just write sine. So you can write S-I-N-E. You can write the abbreviation, which is SIN, but that's what goes in that blank, because that's what opposite over hypotenuse is. All right, in this 30, 60, 90 triangle, labeled as it is, what's this side? Now remember, in a 30, 60, 90, it's either a 1, a root 3, or a 2. Those are the sides. Which one is this? Root 3. And I know it's root 3 because it's across from the 60. So we have 30, 60, 90, 1, root 3, 2. Across from the 30, across from the 60, across from the 90. What's tangent by definition?
Opposite over hypotenuse.
Most of you are going to say opposite over adjacent, but there is another definition, y over x. Either one of those would be fine. The circular definition is y over x. The SOHCAHTOA definition is opposite over adjacent. What is the abbreviation for cosecant? So when you put it in a problem, CSC. Yes, cosecant is CSC. All this information is on your purple sheet. So when we say memorize that purple sheet, all that stuff. All right, now you have your 45, 45, 90. Which side is this one right here? I mean, what's the length of this side right here? 1. In a 45, 45, 90, the sides are 1, 1, and root 2. So if you're across from a 45, you are 1. COT is the abbreviation for what function? What is the name of the function? Cotangent. So you will write the word cotangent. Cotangent, C-O-T. In this triangle, with these labels, what would the cosine of angle theta be? 4 over 5. Because what's your definition for cosine? Adjacent over hypotenuse. And this is the adjacent side. This is the opposite side. This is the hypotenuse with that triangle right there. What is the reciprocal of the sine? Cosecant. So you can either write the abbreviation or you can write out the word cosecant. All right? And that's it. So your quiz is going to have about 8 questions just like this. Some will be pictures, some will be definitions, some will be abbreviations, just like on that. Today we're going to be doing graphing, which is the back of the purple sheet. But as far as the quiz goes, it's only the front. The quiz is only the front of the purple sheet. But today we'll be using the back in class. All right, is everybody clear on what happens Monday? So you still have a whole weekend to get this stuff memorized if you haven't already. Hopefully you got some of it memorized because we've been using it every day. So hopefully, oops, that's not yours. Hopefully you are. All right, so let's get our notes out. let's do a little bit of graphing today. Now, you want the good news? Here's the good news. We, in this class, are only going to be graphing sine, cosine, and tangent. We could graph secant, cosecant, and cotangent, but we're not going to. We're going to stick with the big three. All right? More good news, we're not going to shift them sideways. We're not going to shift them up and down, so we're going to leave them right where they are and graph them. So we're going to make this as basic as we possibly can. All right, number one, A, B, and C are the basic functions. So we need to get these in our notes, A, B, and C, because they are going to be the ones that we use to build all the other ones that we're going to be graphing. So when you graph a sine function, first of all, it's one of your BFFs. I hope this shape looks familiar to you. Remember, sine goes through the origin. Now, it actually keeps going, so it does keep going forever and ever, but we're only going to graph what's called one period of the function, one cycle of the function. So we're going to graph one hill and one valley. That's it. The labels on the basic sine function, the hills go up one, the valley goes down one. So we're between 1 and -1. The period of the sine function, that is the length of this, one hill and one valley, is 360 degrees because it represents one trip around the circle, all four quadrants, 0 to 360. Now, if that's 360, what do you think this label right here is?
180.
180. And what do you think this one is right here?
90.
90. And what do you think this one is right here? Those are the labels straight off your, when we were doing this before, we were trying to figure out where our angles were. Aren't those the labels we used? Here they are, just a line instead of around a circle. The amplitude of this curve is the height of the wave. So the height of the wave is 1. The amplitude of the sine is 1. You guys know what an amplifier is? What does an amplifier do when you amplify something? You make it louder, right? Guess what happens to your waves? If you increase the amplitude, they go up higher. This is a sound wave. Okay. The period of the curve is the distance from beginning to end. So one hill and one valley. That's 360 degrees. Now we will be changing period and amplitude, but for the basic function, that's what you need to memorize. For the basic function, amplitude is 1, period's 360. Who remembers the difference between a sine and a cosine? Remember your BFFs? They were the same, except sine went through the origin, but cosine did this. Remember that? It started up here. Now, don't put this in. It goes on forever, guys. So do you see that same shape again? But the part of it that we are going to draw is called the standard period, and this is what we're going to draw. Now, it looks weird, but that's still one hill and one valley. The problem is the hill got split. So I have half a hill, a valley, and the other half of the hill. This is my cosine curve. The amplitude is still 1. And the period, this is where I'm ending it now at the top of this hill, is still 360. Here is my 180. Here is my 90, here is my 270. The labels are identical. It's the same curve, but shifted. The tangent is a whole different animal. Do you remember, well, I don't know because you didn't watch the video, but sometimes the tangent is undefined. Remember that? Whenever the tangent is undefined, it has a vertical asymptote. So the picture of the tangent that you are required to know is this. At negative 90 and 90, here's the origin. So this is negative 90 and 90. There is an asymptote. The tangent is undefined. And the curve itself is a squiggly that goes through the origin. This was not one of your BFFs, but it sort of reminds you of one of your BFFs, doesn't it? Which one? Remember? The cubing function. It's the cubing function. Except the cubing function doesn't have asymptotes. It's the same shape. The tangent does not have amplitude. Who remembers, what did I say? What's amplitude? What do I mean by amplitude? The height, right? The height of the wave, so just the height. Does tangent have height? See that arrow right there? Does it have height? No, it keeps going forever. There's no amplitude to a tangent. Period is from here to here. This is one period. If I were to graph another period, it would have the same shape. I just keep adding on asymptotes and squiggles. This is one period. How far is it from negative 90 to positive 90?
180.
180. So the period of the tangent is 180. These are your baseline pictures. This is the regular sine, regular cosine, regular tangent. Notice that problem D is another sine, but what? What happened? What did I do? I put a 2 in front of it. Now, the numbers are not going to change the basic shape. That is not going to change. So I'm going to go ahead and draw that. There's my sine picture. Does anybody remember back from chapter 1, what happens when we put a number in front of our function? Back then, it looked like this. I would do something like this, put a 2 in front of the f. And height, somebody said it. Who said it? Height, it is height. So instead of these hills going up 1, they are now gonna go up 2. So reality is they've been stretched, right? I turned up the volume. I made those things taller. Now, putting this number out in front multiplies the height. In trig land, height is called amplitude. So the amplitude of my picture is now 2. Does putting a number out in front have anything to do with this? No. So these labels are unchanged. And my period is still 360 degrees. Putting a number in front multiplies height, which in Trigville we talk about as amplitude. Perfect. All right, next. Negative 3 cosine. is on my paper, draw my basic curve. This is my cosine curve. Starts at the top of a hill, ends at the top of a hill. That's my cosine. Now tell me what that does. Flips it upside down. That's a reflection across the x-axis. It turns it upside down. So this guy is going to go upside down. So in other words, instead of starting at the top of a hill, it's going to start at the bottom of a valley. And then make the hill, and then finish at the valley. What does a 3 do? Multiplies the amplitude. So now I'm going up to 3 and down to negative 3. Again, have I done anything to change these labels? Nope. So 90, 180, 270, 360. For all of these, I'm always going to ask you for the amplitude and the period. So for this one, you will say the amplitude is 3. Please don't say negative 3. Amplitude is the height of the hills. Now, I know I turned it upside down, but isn't the height still 3? Mm-hmm. Amplitude's not negative, ever. Okay? So even though there's a negative in the problem, amplitude is still 3. And my period is still 360? All right, this is fine. Okay, now we're going to do negative tangent. Okay, so again, there's a lot of junk floating around my mind, so before I even start, I like to just give myself a little refresher. This is my regular tangent curve. That's my regular tangent. Now, what am I doing to my tangent in this problem? I'm turning it upside down. So the asymptotes are still at negative 90 and 90. But instead of being an increasing function, instead of going up, it is going to come down. Done. What's the amplitude? Don't have one. What's the period? 180.
What makes it 180 again?
Distance from start to finish. Negative 90 to 90. Your sines and cosines go from 0 to 360, so their period is 360. Uh-oh. Sine 1/2 x. Now, this is my sine curve.
You gotta make it smaller.
Have I done anything to change these labels?
Nope.
No.
Nope, so there's still 1 and negative 1. Who remembers what putting a coefficient on the x, right on the x, 1/2 x, who remembers what that coefficient does? It divides what we used to call the width, but now we're going to call the period. It divides the period. Now remember, your original values of your horizontal are 90, 180, 270, and 360. And I advise you just write those down below. Down below. That's what the labels are supposed to be. But what have I done to those labels now? I have divided them by a half. What is 90 divided by a half?
45.
No.
Oh.
90 divided by 2 is 45.
180.
It's 180. Because dividing by a half is the same as timesing by 2 over 1. So this is 180, 360, 540, 720. Whatever your original labels were, they have now all been divided by 1/2. Divided by 1/2. So your amplitude is still 1. We didn't change that, because a number out here changes that, right? And we don't have one. And our period is 720. So in reality, this thing got stretched. Got a handy dandy little positive cosine curve here. So there's the shape of a positive cosine. It starts at the top of the hill, makes its valley, and ends at the top of the second hill. Have I done anything to change these labels, or should they still be 1 and -1? 1 and -1. The amplitude of this picture is still 1. It hasn't changed. Putting a number here, I know will change my horizontal labels. They're supposed to be 90, 180, 270, and 360. That's what they're supposed to be. But what have I done? I put in a number that divides by 2. So I'm going to divide everything by 2. Remember, this number divides the period. So my labels are 45, 90, 135, and 180. So my period is 180 degrees because I divided it by 2. I don't want you having trouble graphing these cosines. I know it's kind of a funky picture. Your labels are where you cross, you're going to have a label. The bottom of the valley is going to have a label, and the end, which is the top of the hill, is going to have a label. Okay? You should have 4 labels. End where you started, top of the hill. Okay? All right. Where am I? Tangent 1/4 x. So I'm going to remember, tangent is the weird one. It has an asymptote at -90. Oops. Has an asymptote at -90 and an asymptote at 90, and squiggles up through the origin. That's what a tangent does. But I have changed these labels. Would you agree with me? What have I done to those labels? Divided by 1/4. Not divide by 4. I divided by 1/4, which is timesing by 4. So this one is actually -360 and +360. So this has really been stretched. What is my amplitude? What's my amplitude?
0.
Don't have one. Don't say 0, say none. Say none. Or put empty set. What is my period?
720.
720. Distance from asymptote to asymptote. 720. Everybody okay so far? All right, let's look at J. Oh my, lot going on in J. A lot going on. So we have y equals negative 2 sine 1/3 x. Now, when we did this before in chapter 1, I kind of encouraged you to write down the changes, like in words. You don't have to do that, but let's go through it for my sake. What does this negative do? Upside down. What does that 2 do? Multiplies amplitude or height. What does the 1/3 do? Divide period or width. So, the shape that I'm starting with is this. That's a sine curve, hill, valley. I have turned it upside down, so I'm going to graph this. Is everybody okay with that?
Yep.
I know that normally these labels would be at 1 and -1, but I have times by 2, so I'm now at 2 and -2. I know that normally, the bottom of the valley, where I cross, the top of the hill, where I cross, those are my label points. Normally they'd be 0, 90, 180, 270, and 360. But I am dividing those by 1/3. Every single one of those is getting divided by 1/3. Which is the same as multiplying by 3. So this one is going to be 270, 540, what is it, 810, and 1080, if my math is right. So my amplitude is now 2, and my period is now 1080 degrees. The good news is, guys, that's all we're gonna, that's it. Those are the changes we're gonna make. We can do other things, we're not going to. That's it right there. So if you understood that, you're well on your way. Let's look at the next one. 1/4 cosine 1/4 x. This is a positive cosine. Starts at the top of the hill, does the valley, and finishes at the top of the hill. Remember, we have a label where we cross. We have a label at the bottom of the valley, and we have a label at the top of the hill. And it stops at the top of the hill. What's my amplitude? 1/4. So if I were a real teacher and making you graph this like correctly, it would be squished, right? We want graph paper, it would really be squished. It's only 1/4 as tall as it was. Its amplitude is 1/4. Its height is 1/4. These labels are supposed to be 90, 180, 270, and 360. You need to put the correct labels up here, guys. That's why I'm putting these down below. This is my workspace. What am I doing to those numbers? Well, I'm dividing by a fourth, which is the same as multiplying by 4. So this is, it's squished this way, but it's really stretched this way. So let's see, where am I at? 360, 720, 1080, and 1440. Double check my arithmetic. So my amplitude was a fourth, and my period is 1,400. Kishad, are you awake back there?
Yeah.
All right, I'm gonna do one more with you. I'm gonna do this tangent one with you. And then I'm gonna let you work on M and N and see what kind of progress you can make. Let's do this last one together, the tangent L, problem L. 2 tan 1/5 x. Now we know what our basic shape is. There's no negatives, so it looks like a normal tangent. Couple of asymptotes and a squiggly through the origin. And these are supposed to be at negative 90 and 90. Now tell me about that 2 right there. What's that 2 supposed to do? Multiply the height. But wait a minute, this is a tangent. What did we say about the height?
Goes on forever.
Still doesn't have one. I don't care if you double it, it still doesn't have one. There's no amplitude. Now, the reality of it is, and you do not need to worry about this, but I know some of you are wondering, well, wait a minute, what do you mean it doesn't make a difference? The regular tangent looks like that. When I times it by 2, what it does is straighten it out and make it less curvy. In other words, it rises twice as fast. So it's still got the same basic shape, it just doesn't curve as much. When you draw it, you don't need to worry about that. That's just FYI only, okay? So, when I draw my tangent, I don't care if there's a 2 there, a 3 there, whatever. The only time I really need to pay attention to that in a tangent is if it's negative. Because negative would turn it upside down. But as long as it's positive, I'm not going to worry about it. Okay? All right. What are my asymptotes, though? I do need to worry about those. They're supposed to be at negative 90 and 90. What's happening? They're getting divided by a fifth. Now, kids, I know we've had a lot of fractions here. I need you to remember that whatever number is in that spot divides. So if that was a regular 5, you divide by 5. We're dividing by a fifth, which is multiplying by 5. So negative 450, positive 450, which makes my period then 900. All right, M and N. I want you and your teammate there to see what you can do with M and N. We'll give you a few minutes, and then I'll have you come on up and we'll look at what you've got. On the board. M and N.
Well, I'm just waiting for.
So it's just 4%. Oh.
I should have called it work.
Yeah, so it's 90 times. I did not my problem.
Hurry up, leave your phone here. Sure, put your head up, open up your eyeballs. You have these both done? Come on, you got it. Grant, you got one of them done?
Yeah,
Which one are you gonna do?
we'll do M.
Okay, M, you're gonna do the cancer problem, all right, come on and do it. You should label everything and write your period and amplitude. You, yep. You guys had all day yesterday to sleep, because you sure weren't doing your math work. What are you doing? What are you doing? You know what you're doing.
Using my phone as a calculator.
Okay,
I swear.
okay, put it away. We're supposed to have our calculator, right? Okay, well, you're gonna have to find it. Okay, I hate to be hardcore, but those are the rules of the game, no phone. I have ordered a phone thing, like, you know, some of the classrooms have, we're gonna use it.
Hey.
I'm done messing with it. Sneaky little devils think you're pulling something over on me. That orange is sometimes a little hard to see. So we'll have Jacob tell us where everything is when he's done. He's almost done. So, first of all, he's got a nice, Jacob now has a nice little sign. So you wanna tell us, Jacob, what your labels are? They can't see the
Sorry.
letters too well sometimes.
3:15, 6:30, 9:45, 12:60.
And where did those numbers come from? He took 90, for example, and divided it by 2/7, which is the same as timesing by 7/2. That's right. So these are his labels. Now, he didn't mark his vertical, but that remained unchanged, right? So we have 1 and -1, amplitude is 1, and period is 1260. Nicely done, Jacob. Does anyone have a question about that? Okay, then our tangent over here. Okay, we need to make sure that we label. So negative 90 divided by 10 is negative 9.
I have it above. Yeah, it's on the bottom.
Oh, okay, let's put it up here,
Okay.
just for my sake, thank you. So we have negative 9 and 9, which makes our period 18. And there is no amplitude. Perfect. We're 2 for 2 there, folks. Great job. Anybody have a question about that one? All right. Well, here's the happy good news. That's 4-4. 4-4 is due on Monday. All right. Feel free to turn it in early. It's easy. There'll be a little graphing. That's all that's in it. That's due on Monday. Okay? Now, we're going to start 4-7. We're going to start 4-7, but only do a little bit because I don't want to overwhelm you. Look at the directions for 4.7. By the way, we are skipping 4-5 and 4-6. All right, you're not responsible for those two. Trust me, you'll be fine. Okay? Look at the directions for 4.7. Find the exact value. When you see that word exact, it's the same as me saying no calculator. Okay? No calculator. So obviously there's nothing I can do. You're sitting there typing this in on your calculator right now, great. But I'm testing and won't have a calculator for this. You need to be able to do it without. I think you can. This notation, you've used it before. Who remembers in our word problems what we use this notation for? When did we use that? We used that in one special case. Look back at your word problems on page 34 of your notes. When did we use those buttons? Well, we have seagulls. What were we looking for? If we're using that button, we are looking for an angle. Remember, if we want an angle, we use that button. So this literally says, find the angle whose sine is 1/2. Now, I'm going to make you a promise. There are rules associated with this, and it's more than I want you to have to memorize. So, if I don't tell you otherwise, your angle is going to be drawn in quadrant 1. If I want you to draw the angle in another quadrant, I will tell you that. Okay? I will tell you that. This one is in quadrant 1. Here it is. There's the angle. There's theta right there. The sine opposite over hypotenuse. Oh, wait a minute. If that's a 1 and that's a 2, this one is a √3, and the angle across from the 1 is 30 degrees. So theta is 30 degrees. It is that easy, guys. That easy. It's your 45, 45, 90, 30, 60, 90 in reverse. All right. Cosine, find the angle whose cosine is √3 over 2. Find the angle whose cosine is √3 over 2. So you're finding the angle. What you have is adjacent over hypotenuse, cosine. I think it's the same picture. Isn't that 30 degrees? Now, I'm not going to be surprised because every answer I get is going to be 30, 60, or 45. Otherwise, I'll do my seagull problems and type it in on my calculator.
Why is there not theta in this one, but theta in A?
There is theta in this one.
Okay,
Theta is the angle I'm looking for.
okay.
It's the angle at the origin. You're trying to figure out what theta is.
Okay. It just threw me off because I didn't see theta.
I know, I'm sorry.
You're all good.
Alright, we're gonna do two more, and then I'll stop, okay? So, the angle whose tangent is root 3. Now remember, that's root 3 over 1. And that means opposite is root 3 and adjacent is 1. Which, if you want to, means the hypotenuse is 2. And this is the angle you are finding. We'll take a look at the setup here. What do you think that angle is? 60 degrees. This always means find the angle. Just like in our word problems, find the angle. All right, one more. This one is not in quadrant 1. How do I know that?
Negatives.
There's a negative, and you're not going to have negatives in quadrant 1. So I promised I'd tell you, this is in quadrant 4. I know that because I've got the rules memorized. I'm not gonna worry about it, I'm just gonna tell you, it's in quadrant 4. Next year, you may have a teacher who says you need to memorize the inverse drift functions, where they're defined, and I have to memorize that. I'm in quadrant 4. So there's my butterfly bow tie in quadrant 4. Sine is opposite over hypotenuse. So this must be -1, and this must be root 2. Now remember, you're never, ever, ever gonna put a negative on this root 2. That's always gonna be positive. So that negative has gotta go on the 1. And this is also gonna be a 1, not that you have to put that down, but that's what it is. And what kind of an angle was at the origin across from the 1? 45 degrees. Now, here's where things get crazy. Obviously, 45 degrees isn't the answer because 45 degrees is in quadrant 1. That's 45 degrees. What is it when I go this way?
Negative.
Negative 45 degrees. So the answer to the problem is negative 45 degrees. All right, you did a great job today. Lots coming up. Due tomorrow is 4.3. Monday due is 4.4 and memorization quiz.